Welcome all to the third lecture of automobile engineering. Today we are discussing the basic sections of the automobile engineering. So my question is, what do you mean by an engine? What is the purpose of engine? Actually, you studied these things in your previous classes, that is in first year itself. In your basic mechanical engineering, this is a subject basic mechanical engineering, first module, you studied these things. What do you mean by an engine? What's the purpose of engine? And what are the classifications of engines? This is my question. You can see a figure here. It's a working animation. This one is an engine. I think these all sections are familiar to you. All these parts, all moving components. You can see a flywheel, crankshaft, camshaft, piston rings, a connecting rod, crankshaft, timing belt, camshaft. Also, it's where valves are there. All those parts are there, and these are all familiar to you. And this one is the engine. This is the basic building block of all those automobiles or all self-propelled vehicle. You can see that. Okay. So, what do you mean by an engine? An engine is generally an engine means it's a device which is used for the transformation of one form of energy to another. Okay, we know that the energy is required for the propulsion of vehicles. So vehicle or automobile means it's a self-propelled vehicle. So propelling, so we need a energy output or the work output is required for the propulsion. So where we get this work output? So for that we require energy. So engine is an energy producing device. You cannot say that's an energy producing device. It's actually a device which is used to transformation of energy. Actually in engine the energies get transforming. One form of energy is getting transformed to the another form of energy. Okay. So internal combustion engines can be classified as the heart of the engine, and it is considered to be a heat engine where it undergoes different cycles of operation in a separate or a sequent manners to convert the thermal energy into useful work. So we already discussed that engine is a device which is used for the transformation of one form of energy to another form of energy. So in vehicles we know that we are using the fuel such as petrol or diesel. So this petrol or diesel or the fuel possesses some form of energy. The energy possessed by the fuel, that is chemical energy. So energy is present in the fuel in the form of chemical energy. We have to convert this chemical energy to the useful energy. So the energy conversion that is taking place. Chemical energy is converted to thermal energy. So in order to convert the chemical energy of the fuel to the thermal energy, we are using engine. So simply we can call it a heat engine. So all engines are heat engines. So energy conversions are taking place. And these engines are classified into internal combustion engine, that is IC, or external combustion engine, that is EC. In internal combustion engine, combustion is taking place within the cylinder itself. And this product of combustion or the energy produced as a result of combustion is used to drive the system. So what do you mean by this combustion? Combustion is simply the burning of air and fuel or the charge. Air plus fuel commonly known as charge. So combustion means we are burning the fuel. So fuel is burnt in the presence of air. So burning the air in the presence of, burning the fuel in the presence of air and generation of energy. This is what we call as combustion. As a result of combustion, the energy processed by the fuel is generated. That is, chemical energy is converted to thermal energy. That is, heat is generated. And this heat energy is used to drive the components within the engine. And the work output is produced. Okay, that is what given here. You can see here. So internal combustion engine is a heat engine where they undergo different cycle of operation. We will discuss this cycle of operation in the upcoming lessons and convert this energy to useful work. And engine convert the chemical energy of fuel into shaft work output. So the energy conversion taking place chemical energy to shaft work output. Combustion, which is we already discussed, it's also known as the burning. Is a basic chemical process of releasing energy from a fuel and air mixture. Okay, we discussed all these things just now, and based on the operation, we got two types of engines are the internal combustion engine, that is ICE, and ECE, that is external combustion engine. ICE means internal combustion. Example is our four-stroke diesel engine, petrol engine. These are all examples for internal combustion engine. Here in this animation working here, it is an internal combustion engine. In an external combustion engine, it means combustion taking place externally. That is, for example, we can say steam generator or steam propelled vehicle is an external combustion engine where we are using the water is boiled and a steam is generated in a steam generator. Okay, steam means it is at a high pressure and high temperature. And this high pressure and high temperature steam can be used to drive the vehicle or the components, moving parts. There is a piston or cylinder arrangement. So in order to move the piston to and fro, we can use this steam power. And based on that steam power, the crank is rotated and the shaft output is produced. So, but nowadays we are mainly using for the automobile in that is propulsion side. For almost all the self-propelled vehicles nowadays we are using internal combustion engines because they are more compact and energy efficiency is more and the size is very compact. When external combustion is concerned, the size is very large and separate chamber is to be required for producing the steam or external combustion is to be taking place. And the energy efficiency etc. is comparatively low. That's why we are using internal combustion engines most frequently. Okay, here we can see the another working animation of the engine. It is a little more clear. Here we can see the different cycle of operations: suction, compression, expansion, exhaust, etc. I think you are following because you already studied these things. But anyhow, I will discuss these things in the later and upcoming sections. And you just try to understand. The engine consists of a fixed cylinder and a moving piston. The main parts of an engine are a cylinder is there. Inside the cylinder, there is a piston. So, piston is moving to and fro within the cylinder. To and from means up and down. That is top dead center to bottom dead center. The piston is moving. And the driving force is combustion and the combustion energy that is taking place within the cylinder. The expansionic combustion gases pushes the piston, which in turn rotate the crankshaft. We already discussed that there is a combustion. As a result of combustion, that is the burning, the fuel that is we are compressing the fuel within the air and fuel is compressed inside the cylinder and piston is pushing it. And we are pressurizing it. And to this pressurized air fuel mixture, we are giving a small spark or any ignition is provided. And due to that, a sudden explosion or the air fuel mixture get burned out, and high energy is produced. That is what he is given said that expanding combustion gases pushes the piston. So piston is moving downward from top to bottom, and which will give a rotation to the shaft. That is the shaft work output. Ultimately, through a system of gears in the powertrain, this motion drives a vehicle's wheels. the power output produced in the output shaft, the crankshaft, is given to the rear wheels by means of gear trains. That's what we are discussing here, and in the upcoming lessons, that is just clutch is the and the gear trains. Different types of gear systems are used, and then propeller shaft, differential, etc. There are two kinds of internal combustion engines. One is spark ignition gasoline engine and the compression ignition diesel engine, that is SI and CI engine, that is spark ignition, and CI engine, that is combustion ignition engines. Okay, and here we are given a spark ignition gasoline engine, and basic difference means the spark ignition and CI engines are based on the spark, all spark ignition gasoline and combustion ignition diesel engines are different. How they supply and ignite the fuel. In SI engine and CI engine, the supply of fuel is entirely different. In SI engine, we are using a carburetor setup for mixing of the air and fuel. And after mixing this air and fuel, we are supplying this air fuel mixture directly into the engine cylinder through the intake manifold. And spark is produced by means of spark plug. But in the case of an CI engine, only the air is get into the cylinder and fuel is separately given to a fuel injector. Okay, that's the way of different in which both engines are operated. And there include most of these are 4-stroke cycles. This AC engine, SI engine and CI engines are either 4 strokes. Majorly we are using 4 strokes, and there are 2 strokes also there. And 4 strokes means there are 4 piston strokes are needed to complete a cycle. 4 piston stroke means the motion of a piston from top dead center to top to bottom and bottom to top. So 1 cycle means the movement of a piston. 4 cycles means there are 4 movement. It is 2 top to bottom and 2 bottom to top movement. So 1 cycle means 1 revolution of this crankshaft. Okay. And the cycle include 4 distinct processes: intake, compression, combustion, and power stroke and exhaust. These are the 4 strokes that are taking place inside an engine. Here you can see that. Okay, intake stroke is given designated by the figure A, and B is the combustion stroke, and C is the power stroke, and D is the exhaust stroke. I already said you that, and here you can see that the outer section. This is the engine. Okay, inside the engine, and this is a piston, and this one is the piston is connected to the crankshaft by means of a connecting rod, and this crankshaft is rotating 360 degree. So in each 180 degree rotation from the left hand side to the right hand side of the 180 degree rotation, the piston is moving from the top dead center from the top to the bottom position, and from next 180 degree rotation the piston is again moving from this bottom to the top. So the figure A indicates the piston is moving from top to bottom. When piston is moving from this top to bottom, the intake valve is remain open and there is a vacuum will be created. As the piston is moving from top to bottom, there is a vacuum will be generated within the cylinder. Due to this vacuum, what will happen? The air and fuel mixture in the case of spark ignition, or only the air in the case of compression ignition CI engine. If it is SI engine, on the air fuel mixture, that is charge is taken into the system. If it is CI engine, the air will be getting to the cylinder. And at the end of this intake stroke, that is the downward movement of the piston, the valve, this intake valve is closed. And the next 180 degree rotation, the piston is again moving from, that is figure B, from bottom to top. And we know that the air fuel mixture is inside of that cylinder, which is get compressed due to the upward movement of this piston, and their compress and their pressure and temperature goes on rise, or that is increased. At this stage, at the end of this compression stroke, we are providing a spark. A spark is initiated by a spark plug. At the top, you can see a spark plug. At the top, there is a spark plug. The function of spark plug is to produce a spark. A spark is generated. Due to this spark, what will happen? Due to this spark, the air fuel mixture gets burnt and the expansion is taking place. That is the power stroke. Power means the piston is moving from top to bottom again, and the valves intake and exhaust remain closed. And here the power is produced, okay, and which is given to the shaft work, that is the crankshaft. And again, at the last, the exhaust stroke. After the expansion, these exhaust gases are there. These gases are expelled out through the exhaust valve, and the exhaust valve is remain open in the exhaust stroke. Okay, so there are four strokes are the suction, or we can say it as an intake, suction bar intake. Secondly, compression, and third one is expansion, or we can say it as a power stroke, and lastly exhaust stroke. So in these four strokes, the power is produced only in the third one, that is in the power stroke. So in a four-stroke engine, at four strokes, there is only one power stroke is there. So one stroke means it's 180-degree rotation. So intake is take 180, so combustion is take another 180, and there's two revolution of crankshaft in a four-stroke engine. Crankshaft is take two revolutions. So one complete revolution there will be two stroke. So each stroke means 180 degree. So in two stroke it will be just to 360 degree rotation. So here it is total 720 degree rotation of the crankshaft is there. Okay. This is the working of four-stroke engine. In two-stroke it is only difference is that the valves are replaced by the ports, and only two strokes are there. And the engine design is somewhat some difference of the slightly different. Okay. And after that I would like to say that in the case of this CA engine also, only difference the four strokes are same: suction, compression, expansion, and exhaust. Arrangement of valves, everything is same. Only the fuel injection is different. Air fuel mixture is injected in the case of spark ignition. In CA engine, only the air is injected after get into the system during suction, and fuel is injected directly into the compressed air at high pressure and high temperature, and then this combustion is taking place. That is the only difference. Okay, so that's all for today. Thank you for watching.